Metricon Prism Coupler. The prism is installed. There's also a sample installed here. This actuator actually pushes the sample against the prism where the coupling happens. Right now the helium neon laser is on. To change to the other wavelength, there are the knobs here for closing and opening the desired laser. Right now the yellow laser is on. To switch it back to helium neon laser, we have to open the 633 nanometer here and close the 594. So when both the wavelengths are to be used to measure one at a time, we can turn on the laser and let them warm up, and then just by using these knobs we can open the laser which we want to use for measurement. These are the two micrometers which adjust the mirror inside. The position of this micrometer is very critical. So the approximate values are labeled here. In millimeters. There is this pneumatic switch here to enable the actuator, and there is a pressure gauge and a regulator. The pressure gauge is here. The regulator is to be adjusted to set the pressure from 30 to 40 psi. The power supply for the helium neon laser is mounted on the case here. There are also heaters to heat the temperature, this sample, and monitor the temperature. The temperature controllers are here for the prism and the sample holder. Right now the set points are 25 degrees Celsius. This is the Prism Coupler, which actually drives the motor, and there's an offset knob to adjust the level of the signal and the gain to increase or decrease the gain. After boot up, clicking on Metricon MCU icon will start the application software, and here this is the measurement parameter screen where we can set the wavelength, one of the three, 473 or 594 or 632.8 nanometers. I'm going to select the helium neon laser. Each prism comes with a code numbered on it. This is a typical prism here. So the code is labeled on the prism coupler. This is the prism here, and the code is to be entered in the parameter screen. Also the temperature whatever the temperature set at the controllers. And the step size could be selected, and also the start and the stop distances of for the scan mode could be changed. Once all the parameters are entered, click OK. And then the first step to be done is auto referencing, where the prism will rotate over the entire scan distance and locate the laser. All the system interconnection cables are labeled and numbered, and the Prism Coupler module communicates with the PC using a serial port. After the reference peak is located, once you see OK here, clicking on it, it will show the whole scan and where the two peaks of the laser are located. And now to start a measurement, you can enter a sample ID. Number, and then once it is entered, click on measure. So the start and the stop units are the total range of the scan length on the x-axis, and this is where the modes have been located. The Prism Coupler, the coupling is very important, where the prism is pushed against the film, and the number of modes is dependent on the film thickness and the refractive index of the material. So I'm using a sample which is about 9,500 angstroms. Here the thickness is displayed in microns, and the refractive index is 1.46, which is silicon dioxide on a silicon wafer. So once the scan is over, we can print, and we can print the intensity graph as well. This is an option. It's a thermal printer, Seco DPU 414, connected to the PC via the parallel port. There are also options available for manual measurement, and also can do calculations or recalculate. At any point of time, clicking on parameters will open the parameters window. Now I'm going to use the same prism but change the wavelength to 594 nanometers. So every time we change the wavelength, we have to do the reference measurement again. So first, close the shutter for the helium neon and open for the 594 nanometers. And you can notice, because this laser is slightly powerful than the other one, so I have to adjust the offset to bring the scale within 80% of the full scale. So once I am ready, I'm doing the auto reference now. So now the reference peak is found with the new laser, that is the second one, 594 nanometers. So I'm going to enter sample ID and start a measurement. So these are the results plotted in the new labeling. I'm going to print the graph. While it is printing, so I'm going to show how to load the sample. I'm using a small piece of wafer with a film on it. So you place the sample against the prism and turn on the pneumatic switch. So and then open the shutter for the laser, whichever is desired. It's always safe to close the top window to prevent exposure to the laser.